Hi, in this video we are going to see how we can create our own bot using RAG. So in this video we are going to see how we can use different documents to create a vector store and then use LLM queries to answer the user queries. So first let's get into the architecture of our bot that we are going to create. So here we are going to use three different documents. One is HTML, one is PowerPoint presentation, Adobe, and then is the PDF file. And then we are going to extract data out of these different documents. We are going to store it into a vector database. And then when the user queries, we are going to query the vector database, and then LLM is going to answer the user query. So let's get started. So first we are filtering out the warnings, then we are importing important classes and libraries from Unstructured. This time you can see chunk by title. We'll see how this function is being used. We also see partition MD, which is used to read markdown files. Partition PPTX is for extracting data out of presentations, PowerPoint presentations, and also ChromaDB, which we are using as in-memory vector database. Then we are going to set up the API's keys for unstructured client. Now we are going to see what kind of data do we have in our markdown file, in our presentation, and also in HTML. So this is the PDF file, the screenshot of the PDF file which we are going to use, and you can see it has different tables. It has heading, it has text. Second is the PowerPoint presentation, which has this kind of data, and also we have this markdown file which has the title, which has some text, which has also some diagrams. So first we are going to start with the pre-processing of the PDF. So here we are attaching the file which we want to extract data out of. We are opening the file. Then we are using this partition parameters function, which is using vision transformer internally to extract data out of the PDF. Here you can see we are using YOLO X, and it will be internally drawing bounding boxes around different section of the documents. And also we are saying infer table structure as true. It means it is also going to read the table data and extract that data out. Once this request is made, we get a response from this library Unstructured, which extract data out of this PDF. So this process is little slow because vision transformer is like little heavy and it takes time to extract all the data out. Once this will be done, we'll also be printing the dictionary of the first element that we extracted from this PDF. And we'll also see, we'll also load all the tables. So we can see in this, if category is stable, then we are loading all the, so first of all, there's a loop on the all the PDF element, and if the category is stable, then we are creating a list out of it and also then parsing it into HTML format. This is to print out the tree structure. Let's wait for this to be completed. Till then, we can see what is happening next. Okay, so in this PDF, like we are loading one image from the PDF itself, which say in which we can see the references of the research paper. So if we want all the elements from this reference section, here you can see if element.text equal to reference and category is equal to title, then we are like loading all the elements into this reference title table, and 0 specifies the first reference. We are converting that this reference title to dictionary and then saving the ID to the reference ID. And then we are iterating over all the elements in the PDF elements, and this PDF elements we extracted out from this PDF, which is still loading, and we are seeing if the reference ID which we have here is equal to metadata parent ID, then we are like printing those elements. And same thing, okay, so basically what we are doing, we are printing all the elements here which are part of the reference section, that reference section which we generally see in the end of any research paper. So that is the thing. So we are printing out those elements, and in the next line we are filtering out those elements, because the PDF element that are finally going to go in the vector store, we don't want the reference section inside that, so we are filtering that out. So using this line we can filter out any part of the elements that we have loaded. Once that is done, then we are also filtering out the header. So we'll see in the image, once the above steps are completed, that there is one header section. I think there is this section also. So you see here OCR free document understanding transformer and page number. So we don't want in every page we can see this, and we don't want that to go in vector store, so we want to filter that out as well. So here we are saying that if category is equal to header, we are storing that into header, we are converting into a dictionary to see the output, and then again we are like filtering it out. We don't want that section, so we are filtering that out from PDF elements. So let's wait for the above process to get complete. Till then we will also move on to the next steps. So then comes the PowerPoint processing part. So here simply we are just giving the PowerPoint presentation file name and getting all the elements out of that PowerPoint. Same for the markdown file. We are using this partition MD function to get the markdown elements. Now comes the part where we load all the documents into the vector DB. So the PDF element that we have extracted and filter out, the PowerPoint elements, and also the markdown elements. We are combining all those elements, chunking it by title and storing it into the elements. So chunk by title is also coming from the unstructured import statement. So it will automatically store, or it will automatically chunk all the data by title. Then we are importing some statements from LangChain, such as Chroma, document, and OpenAI embedding. Then we are creating an empty list of document. We are loading up all the elements that we have stored together. And then what we are doing, we are removing the languages section from the metadata. We are also creating a new column in metadata called source, so that we can use it to filter out later, and that would be the file name from where we got that data. For example, if we got some data from markdown file or PowerPoint file, so this source will specify that file name. And then simply we are appending it to the document list. For all the elements that we have extracted, we are appending to document, and here we can see metadata is this metadata from which we have removed the language and added a source, and element.text is the actual text which were there in the documents. Then we are loading up the embeddings, and then using this command chroma from documents document embedding, we have created a vector store. And this retriever is like used for a query, and the search type is similarity. So based on the query, it will try to search like what is similar to what inside a vector store and return the response to the query. So that's a retriever. So let's see if our previous processes has been now completed. So yes, PDF element thing is now completed. We can also see like the first element of this PDF, which we have converted into a dictionary. This is a PDF file with the file name, and then what we did, like we extracted the table out of it, and you can see we have printed it in a HTML form. Then comes the references section that we wanted to filter out. So here we have like the image of that reference section. So let's take out the first element also from that reference section, and here we get one element ID which refers to the first part of this reference. And Okay, so the references title that we see, it is actually that the references title here, that is the thing which we have loaded here, and also we can see the type title. And if we do reference ID, so it will load up the ID of this into the reference ID, which is this one. So maybe let's print that as well. 05. Okay, so this is the element ID, sorry, yeah, so this is the element ID, reference ID. Now what we are going to do, we are going to iterate all the element and just going to print all the elements whose parent is this ID. And when we did so, we are able to exactly get this Afzal, MZ and something. So we are able to get that out, and we did a break statement, so it didn't print all the references, but we see like we are able to retrieve the references, and now we are going to filter that out from our PDF element. And in the similar way, we want to also filter out the header part, which we have seen OCR free document, so this can be also filtered out. And that is how we have prepared our all the PDF elements after the filtering out process. Now comes the part of pre-processing the PowerPoint, similarly the markdown files. Now we have loaded up everything into the vector DB, and now we were on the part where we were loading up the content into the vector store. That is also done. After that, we have created a retriever. Okay, so there is some error. Try filtering complex metadata from, so it is saying there is some complex metadata somewhere which the vector store is not able to understand. Let's try to debug this. So there is this filtration process that we can also use, where it says using chroma auto utils we can filter out some complex part. So let's try that out if it works. Let's hope for this to work. Okay, now we can see it has successfully compiled, and now we have created this retriever. Now we are importing everything from LangChain. Now we are creating a prompt template, and template is this: you are an AI assistant for answering questions about the donut document. If you are given the following extracted parts of a long document and a question, if you don't know the answer, just say I'm not sure. Don't try to make up the answer. We are giving this so that the model do not hallucinate. If the question is not about donut, politely inform that you are tuned to only answer the questions about donut. So don't go out of the context and give any answer, just stick to donut part. Here we are giving the question and the context and then the answer. So this is a prompt template, and we can see the question and the context as the input variable. So let's run this. After that, OpenAI temperature 0, we are loading up the model. Load QA with source chain. So this is also a function from the LangChain which we use, where we give the LLM model and also the type of chain. Question generator chain, LLM chain, and then conversational retrieval chain. Here we give the retriever which we created out of vector store, and the question generator chain and the doc chain. So this is how we can like create a conversational bot using the LangChain. And now comes the part where we actually get the answer by querying this QA bot that we are trying to create. How does donut compare to other document understanding models? So let's see what it gives out as answer. Also you can see, since the input variable were question and context, so currently there is no chat history, so that's why the context is empty and there's only the first question. Donut is a document understanding model that do not rely on OCR and can be trained in an end-to-end fashion, making it faster and more accurate than conventional method, sorry. And you can also see the sources, like from which sources it was able to get this data out from, which is the PDF and the PPTX, which we have initially queried or stored into the vector DB. Now we are also creating a filter on the retriever part, and we are saying just stick to the markdown file to answer. So let's run this again. There is now the new retriever which we are going to use, and this remains the same, and also this remains the same. So once this filter chain is created, we can now invoke. How do I classify documents with Donut? So it should stick to the markdown file for the source to get the answer out. So we can see it is in the sources giving or using just the markdown file. And Donut is a document understanding used for document classification. And yeah, so basically we are able to create a bot. So in this notebook, what you have seen, we are able to use 3 different kind of documents. We are able to store it into a vector store, and then we are able to query it using the LLM RAG method. And that is how you can also create your own chatbot, which is based on different documents, basically which is extracting data from different documents. Thank you.